Welcome everybody to my Intro to Quantitative Research for Qualitative Researchers course. You may remember in the first lesson, we learned about how to build a bar graph that follows all the basic principles of good data visualization, and how to communicate the results to readers through clean, clear data visualizations. So what I'm saying is we're basically professional data viz people now. But, okay, before we go ahead and put that Dr. Chad Certified Data Viz Pro on our LinkedIn profiles, let's do a little bit more work and learn a few more things in case anyone asks for something that isn't a bar graph. Our first lesson, of course, did look at bar graphs, which is one of the 3 basic graphs you should learn. Today's lesson is going to dive into the other 2 types, and some of the cool things you can do to visualize data in ggplot to help learn more about data you're using and how to communicate what you learned to people clearly. So let's start with a very common task. We have a variable we think we want to track over time. The prototypical goal of tech companies, businesses, is to have graphs that go up and to the right. This is what they mean. Metrics like users over time, interactions over time, profit over time. All of these metrics more or less should go up, e.g. increase profit, and to the right over time. To do this, we should use our friend, the line graph. This is really just about the only time you should use a line graph. The connection between points, as we in the biz call the line, implies that the relationship is a continuous one rather than a set of discrete points, and practically that more or less only happens when you have time mapped on your x-axis. And note, there are other opportunities, but this is the one you will likely see the most often by far. Despite its limited use case, I have line graphs as one of my 3 core graphs because this use case is so common in business settings and is a must-have in your toolkit because of that. So let's talk about a research question using the babynames dataset, learn how to build one in R, and some best practices / cool tricks we can do with them. So because our data set is baby names, I'm immediately curious about people who name their kids after celebrities. Who isn't? How many people name their kid Beyoncé, and how has that changed over time? So as we do every time we start an R session, we think about the libraries we need to load to do what we want to do. Today, that'll be the baby names library, ggplot2, and dplyr. So let's go ahead and do that. Okay, we've got it loaded, and as you might remember, the next thing we always do when loading a dataset is to check it by typing the head command to see the top 6 lines. So interns, go ahead. Okay, all looks good here. No surprises. But that's most of our goal for data entry. My Meemaw used to tell me, if your data entry is exciting and filled with twists and turns, you're doing something wrong. Boring is good. Now it's time to learn something new, how to filter data. For my research question here, I only care about people named Beyoncé, so I don't need all the Marys, Annas, Emmas, Elizabeths, Minnies, and Margarets in this set. To do that, I'm going to use the dplyr library, brought to you by the same people who created ggplot, specifically the filter command. The syntax here is fairly straightforward, and we've seen all of this grammar before. We have a new data set, an arrow to indicate whatever is to the right of what we want the new data set to be, and some syntax to the right of that. In this case, we're creating a new data set named df Beyoncé, short for data frame Beyoncé, an arrow, and then filter data equals baby names because we're using the baby names data set, a comma, and then name, a double equal sign, and then Beyoncé in quotes. There's a couple easy places to make mistakes. First, make sure you do the double equal sign here. It's a programming thing, don't worry about it, just do it. Also, put Beyoncé in quotes because it's a string or a group of letters. If you don't put it in quotes, R will look for an object in memory called Beyoncé and none exists, so it'll just kick an error back to you. Once you type that, go ahead and type in your head command to see what happens. My interns have done this for me, and it looks great. We have all the children named Beyoncé in America, and it looks like the first time we had more than 5 Beyoncés in America was 1998. It's really good to know. So let's go ahead and visualize the Beyoncé data and see how it looks. The syntax here should look somewhat familiar because it's very similar to the bar graph syntax we previously learned. We first set up the data structure and basic aesthetics with ggplot, parentheses, data equals df Beyoncé, comma, AES, x equals year, y equals n, and then 2 parentheses at the end. That tells R to use the df Beyoncé dataset and the basic aesthetics should be year on the x-axis and the number of Beyoncés in a year as the y-axis. Then we add our plus sign and tell R what type of graph to use for the first layer. In this case, it's going to be a line graph because we're trying to visualize data over time, and that's the best type of graph to use in this case. So we'll add geom line, parentheses, and nothing in the aesthetics for now as our first layer, and see what happens. Okay, so we take a look here. This is a pretty interesting, if not well-principled graph. We can see growth in the number of Beyoncés from 1998 to 2001, a spike in 2001, and then a decline with some growth and falling until 2007, when it finally has one last peak and declines for good around 2010. Honestly, that teaches me a lot about the name Beyoncé in America right there, even without adding anything to it. But let's make this a principled graph by going through the steps we went through last time, and we should go through every time. 1. A simple presentation. 2. An honest presentation of data. 3. Highlight the primary takeaway through a clear title, use of color, and labels. 4. A self-contained graph that doesn't need any extra context to understand what it is and what it says. And finally, number 5, as always, a simple presentation that Coco Chanel would be proud of. Okay, step 1 is to use the simplest type of graph that communicates the relevant information, which we've already done here. Line graphs, as we said, are one of Dr. Chad's 3 basic graphs, and the data fit the primary use of line graphs, so we're good here. Check that one off. Number 2, an honest presentation of data. There are multiple ways to be dishonest with data, but the one I'm most worried about here is the y-axis scale. In general, it's bad practice to just go with a y-axis that's slightly above the highest value, because that can exaggerate trends in the data. So we should try to come up with something meaningful here. Because we are only looking at the name Beyoncé over time and aren't trying to make comparisons to other popular names in general, thinking like an Ashley or a Jenny from the 90s, I don't think we need to make the y-axis reflect the relatively low number of Beyoncés. But we shouldn't leave it at like 375 or wherever it is now. Let's change it to a nice round number, maybe 500. It's not particularly scientific, but I think that's a good balance of showing the contrast between years without being dishonest, so I'm going with it. All we need to do is add another plus sign and the code ylim parentheses 0, 500, where 0 is the lowest value because this dataset doesn't have negative numbers, of course, and 500 is the highest value. We don't need to do anything to the x-axis limit here because we don't necessarily care about years with 0 Beyoncés, especially because we can assume the data captures the first year we had more than 5 Beyoncés. I think we're good here. I think there's nothing else dishonest about this graph, so interns, go ahead and check off box number 2 for me. Now, let's move to point number 3. Highlighting the primary takeaway through a clear title, use of colors, and labels. Right now, this graph has none of these things. So the good news is just about anything we do would be better than what we have. Let's start simple. Let's add a title, an x-axis label, and a y-axis label. The code here is just about adding more aesthetics to the graph through the plus sign and appropriate code. So let's do that now. We'll add a y-axis label of number of children named Beyoncé, an x-axis label of year, and a title that describes the major takeaway from the graph. How about more children were named Beyoncé in the US in 2001 than any other year? We'll do that through the use of the XLab, YLab, and GG title aesthetics. Interns, go ahead and work your magic. Very nice. This is starting to look really good, but I wonder if we can add some more labels to this to even make it more intuitive. First, I think an easy victory here is to add points representing each year so we can know exactly which year is which. Right now, we have to guess about where 2002 or 2007 or 2014 are on the graph, which is not ideal. But if we add a point at every year, I think that will really help. So let's do that using the geom point command. The good news is we don't have to do anything else with that because geom point inherits the aesthetics from earlier. So if we just add that with empty parentheses, we'll get basic points at every year. Interns, do that and then we'll take a look. Amazing. This looks even better. Let's take the win right here and congratulate ourselves. Great job, everybody. But what if we could do even better than that? So, I have a hypothesis that what happened here, as Beyoncé became more famous, people were more likely to name their kids after her, but then as she became super famous, it became cringe, as the youth say, to name your kid after her, and it decreased over time. Let's take a quick look at Beyoncé's discography and see if there were big albums released around some of these years and go ahead and label them on the graph. Okay, this is really interesting. We have a cool story here, I think. In 1997, there were fewer than 5 Beyoncés born in the US. In 1998, when Destiny's Child's self-titled album came out, we saw our first time over 5. Then it increased again with The Writings on the Wall and peaks with Survivor. It goes down for a year. Destiny's Child stopped releasing albums, but jumped a bit again with her first solo album, Dangerously in Love, and then drops when she doesn't release anything for a couple years, spikes a little again the year after B-Day. After that, it goes down consistently because presumably Beyoncé is big enough where people are less comfortable naming their child after her. The whole story is that from 1999 to 2008, when Beyoncé or Destiny's Child released albums, people became fans and named their children after her. It's a pretty interesting story and one we can capture on the graph through some creative labeling. How do we do that, you ask? That's an excellent question. We do that through adding another layer, or layers for multiple labels. And specifically, we use the geom_label command. Geom_label has a few elements to it. Label, which includes the text you want on your graph, X and Y, which represent the X and Y coordinates of where the text should be centered, and in this case, we're changing the size to 3 because that looks better on our graph. You can experiment with size, color, style, etc., but we're going to keep it simple here. So if we wanted to label Survivor, we would have to think about what the X and Y coordinates are for that album. Remember that the X-axis is year, so the X coordinate is going to be 2001 because the album was released in 2001. The Y-axis is number of children named Beyoncé, so for the Y coordinate, we'll find the actual number of children named Beyoncé in that year. We can do that by looking through the DF Beyoncé dataset because it's, small enough. But, sort of, the big question is, what if it wasn't? The easiest way to do that is to filter by DF Beyoncé by year, and that code is right here. We run that, and it turns out that there are 353 Beyoncés in 2001. Because we don't want the text box to overlap with the line, let's bump it up a little bit so the text displays right above the line in an easy-to-read format. Maybe a Y coordinate of like 380 will work. So let's go ahead, interns, add the geom_label layer. Well, that is pretty cool stuff right there. We just need to lather, rinse, repeat for the rest of the interesting years. Let's do 1998 for when Destiny's Child released their self-titled album, 1999 because that's when the real steep incline starts, 2001 for the peak, Survivor, 2003 for the small increase after the release of Dangerously in Love, and then I guess 2006 for the final peak marking the release of B-Day. There's lots of great albums left from Beyoncé, but no real interesting data points exist on the graph, so we don't have any real love for Lemonade or Homecoming in our graph, but of course they will always remain loved in our hearts. The code is very similar to before, just changing the X and Y coordinates. I want to point out 2 quick things though for your future knowledge. 1. For the Destiny's Child self-titled album, I did an X of 1998.5. This is because geom_label centers the text over the X coordinate, so if you do 1998, it'll end up being slightly off the graph. I nudged it over 0.5 to make it fit the graph. These types of choices are purely aesthetic. Feel free to play with them on your own, decide what you like best. I promise you won't break anything if you do. That's the best part of R. The writings on the wall, I added a slash and the letter N because that's how you tell R to do a line break in the middle of a text block. I don't know why, nor do I need to know why. I just know it's what you do, so I do. It's weird, that's all I've got there. But again, an aesthetic choice I made because I thought the title was too long and it looked better on, 2 lines. Do what you think is best here. One last thing to do is call the ghost of Coco Chanel and see if there are any accessories we can remove here. The only possible ink I see wasted here is that gray background. Hadley Wickham likes it, I don't, So I'm gonna go ahead and get rid of it, use the plain black and white background. This is done by adding just a plus sign and then adding theme_BW parentheses. Let's take a look and see how that ends up. Okay, done. Great job. We've created a great graph here. We could maybe change the title if you wanted to "More Children Were Named Beyoncé the Year Survivor was released" or something else, but I'm happy with this. I think this is great. You can feel free to perfect it on your own time. Now, we're gonna move on to the final type of core graph, the scatterplot. The scatterplot is good for visualizing two-dimensional data types that aren't changed over time. The continuous nature of the line implies that there's a connection between the points, time, but the disconnected nature of the points on a scatterplot implies that the points are all individual. This is bad research practice. Please don't do this on your own. Please, please, please don't do this on your own. But let's think of a good research question related to baby names that doesn't require something related to time. So we're starting with the DF common dataset. We then create a new dataset, DF common new, the arrow, and then DF common with what we call a pipe here. To count occurrences, we do count, parentheses, name, sex, and n_new equals n, and the pipe, the percent greater than sign percent. What this does is counts the occurrences of each combination of name and sex in DF common. The result is a data frame with the columns name, sex, and n_new, the count. We're now going to spread the sex values into separate columns. That's going to be spread sex, n_new, fill equals 0, pipe, which creates the sex column, converts it into two separate columns, F and M, with counts as its values. If a combination of name and sex doesn't exist, it fills that value with 0. We're going to calculate the total and then shares. So we have mutate, total equals F plus M, M_share equals M divided by total, pipe. Total, of course, now is the sum of counts for F and M, F_share, the proportion of F in the data set, M_share, the portion of M in the total. We're going to filter the data, filter F_share less than 0.85, M_share less than 0.85, and the total is greater than 1,000, less than 4,000. What this does finally is keeps F_share where it's less than 0.85, M_share is less than 0.85, and the total is between 1,000 and 4,000. This code essentially processes a data frame to count occurrences, spread them into separate columns based on sex, calculates proportion, and filters based on specific criteria. So let's check how big this data set is by using the dim command, which is an abbreviation for dimensions. The output here will be the number of rows by the number of columns. Let's see what we find. Okay, we're at 39 rows and 7 columns. That means there are 39 names that meet the criteria we set out earlier. That's a manageable number to graph, so let's go ahead and get started. Once again, the code should look familiar here, and that's a good thing. Repetition is one of the best ways to remember something. Meemaw used to repeat that all the time to me. Hopefully seeing those syntax repeatedly helps you remember it and understand how small changes in the code make changes in what graph you produce. So interns, go ahead and show me what you've got here. Okay, this looks great. Here we go. We have a scatter plot of names by sex. Look at the dots. Each of the dots represents a name, and they're plotted at the point where the X value is the number of female babies in 2017. Y is the number of male babies named that in 2017. Very cool. Although there's a clear way we can improve this, we've included the names on the plot. So let's add another layer here. We'll add a geom text repel here, which is a nice way of doing text and points at the same time. If you use regular geom text, it'll center the text to the point, which is quite unfortunate to look at, but repel uses an algorithm to repel the text away from the points in a way that makes it readable. Interns, go ahead and we'll see what that looks like. This looks great. There's lots of interesting names here. I never would have guessed there were so many Oakleys out there, and that it was such a gender-neutral name. I'm not sure I would have guessed the name Charlie was almost evenly split, or that both spellings of Elliot are just about equally gender-neutral. It's all very interesting and things I never would have guessed. It's the power of data viz to really help us generate hypotheses, learn what we're talking about here. Once again, let's revisit our 5 rules of data visualization, and we can start improving this. 1, a simple presentation. 2, an honest presentation. 3, we highlight the primary takeaway through a clear title and the use of color and labels to highlight the most important takeaways. 4, a self-contained graph that doesn't need any extra context to understand what it is and what it says. 5, a simple presentation that Coco Chanel will be proud of. My Mima used to always say, repetition is the key to remembering something, and that's why we're repeating this over and over again. So let's go to the next step. Let's clean up the graph, create a simple and professional presentation. We already know some of the basics here, and I'm gonna do a couple things at once to help speed this up. I'm gonna label the axes, the title, and use our cleaner theme all at once. Well, our interns are gonna do that, so go ahead, interns. Let's see what we've got. Okay, this is simple and easy to understand. Nothing here I would call dishonest, but let's come back to that one again when we're done, just to be safe. The next thing to do is highlight the takeaways. We've already done a good title, so gold star for us. Beyond that, I think there's a couple of other things we can do. First and easiest is to highlight the names we call out in the title: Oakley, Charlie, and Skylar. That will require a couple of code changes, and I'll walk through those here. First, we need to go back to our main data frame and tell R which points we want to highlight. So to do that, we'll create a column named color, which will be red for those 3 names that we care about and black for all the others. We're going to use dplyr and piping here and the mutate command to create a new variable. Mutate syntax is mutate, name of the variable equals a formula for the new variable. In this case, we want it to be red for Charlie, Oakley, and Skylar, and black for all others, so we'll use the if-else command. The syntax here for if-else is if-else, parentheses, variable name that we want to use, in checks if elements of one vector are in another vector. So in this case, are any of the elements of the vector we're about to type in the name vector? If they are, make it red. If not, make it black. So let's apply that to the ggplot template we've made, adding an aesthetic to geom_point of AES color equals color. And then we'll do scale color identity at the end. It'll look something like this. Okay, this is very nice. We can see the big 3 names we wanted to highlight in a nice red color. Your eye is immediately drawn to them. This is great. We could probably stop here, but I want to present one more option to drawing attention to our measure of gender neutral, which is a 1-to-1 equivalence between the genders on these names. The way we can do that is to add a line where y equals x. The number of boys named something versus the number of girls named the same thing. To add this line, we use a simple code called geom_abline, which is a line specified by slope and intercept. My 7th grade math teacher, Mrs. Borshevitz, would be very disappointed in me if I didn't mention the slope-intercept form of line here, y equals mx plus b. It's not really important to the point, it's like the mitochondria being the powerhouse of the cell, but hopefully she watches this and is proud of me. The code here is fairly straightforward. We're just going to add one more geom to the graph here, geom_abline. And because I think a solid line is too aggressive, I'm going to make the line a little more subtle by adding line type equals dotted to it. Here's the full code, and now let's see the output. The line there shows which points are closest to a 1-to-1 ratio, which I think is a nice touch. There's also an argument for making it too busy. Either way is fine. I prefer it this way, and I want to err on the side of showing you a couple more options versus keeping it too simple. You can decide later on your own what you like, but I want to show you all the options you have. Let's go back and do a quick audit to make sure this fits our 5 rules of data visualization. Do we have a simple presentation? Yes, we picked one of the 3 basic types, which is always a great start, and we presented it in a clear, concise way. Gold star for us. 2, an honest presentation of data. Yeah, I'm not sure what there is to lie about here in a graph about names, but I'm fairly confident we didn't do anything dishonest. Gold star for that. We're 2 for 2. 3, highlight the primary takeaway. Yes, look at that. We highlighted the important names in red, we gave it a clear title, and we drew a cool line of y equals x to draw more attention to where names are compared to this perfect 1-to-1 ratio. 3rd gold star, we're doing great. 4, a self-contained graph that doesn't need any extra context to understand what it is and what it says. Yes, we have names, we have clear titles, we described everything well here. I don't think anyone would need any more context to understand what this graph is trying to say. Yet another gold star. 5, a simple presentation that Coco Chanel will be proud of. Yes, absolutely, we kept it nice and simple here. Again, the only way to simplify it more would be to maybe remove that line, but reasonable people can disagree on that point. I don't think Coco Chanel would shame me, so I'm gonna say gold star yet again. That's a perfect 5 for 5, everybody. That's great work. And if you can do this, you are better than any of the AIs you see in my DataViz Sanity playlist. So if you haven't looked at that yet, check out my YouTube channel, youtube.com/DrChadStats. You'll see the latest and greatest from the Dr. Chad auditorium. It's amazing. Watch it, love it, learn it. But if you can do this, you are strong. I'm willing to certify you as a Dr. Chad DataViz expert, as long as you watch the other videos in this playlist. So with our checklist done, I'm going to confidently say that we have made a top-notch line graph, a top-notch scatter plot, and we have really practiced these 5 principles of data visualization. Great work, everybody. If you go through this and you can do this code, replicate it, do it on your own projects, you're going to be strong. You're going to be able to do good stuff. Well done, everyone. Take the win. We're going to see you all next time. Thank you all. This is it for lesson 2 from the Dr. Chad auditorium.